today we are going to be talking all about ratios. So we're going to be looking at what is a ratio, how do you write a ratio, how do you know if a ratio is equivalent to something else, and we're going to be looking at a name. A name that we give to ratios that are equivalent to a given ratio. So we're going to be looking at values. That's what we call those as values. So first up, we need to know what are ratios. What are they? It's just like a fancy word, right? So what is that fancy word and what does it mean? Well, ratios is a word that means comparing two quantities or more. So you're comparing quantities of things. So ratios can be written in many different ways. So first, we're going to look at the word ratios. And ratios is a comparison of two or more quantities. All right, so ratios compare. They compare. Alrighty. Now, we can write ratios as a part to part, comparing a part of one thing to a part of another. You could compare them as like a part to a whole or a whole to a part. So, let's say, for example, I have some triangles and I have some circles. Okay, my parts of this are triangles and circles. So a part to a part. They compare a part to a part. So in this example here, we would have triangles to circles. Or you could have circles to triangles. It just depends on like what they're asking for, and we'll talk about that in just a second. You could also do a part to the whole. So like you could have triangles to all shapes. You could have circles to all shapes. And you could have a whole to a part. Okay, and this would be like all shapes to triangles or all shapes to circles. So you have three different types of ratios that you can write. Part to part to whole, or whole to part. Okay, let's do an example. Okay, let's do a really quick example. So example 1. Let's say that I have some dogs. So I'm going to draw some dogs. Okay, and then I have some cats. So let me finish drawing my dogs. And you don't get to make fun of my drawings, okay? So let's say I'm going to draw a dog. Here's another dog. Okay, and then I have a cat. And I have another cat. Okay, so I have cats and I have dogs. Okay, I want to know how many cats to dogs do I have? So cats to dogs. If it's asking for cats to dogs, I have to put cats first. So the number that represents cats has to go first because that's what it's asking for first. So I would add up my cats. 1, 2, I have 2 cats. 2, 1, 2, 3 dogs. So a ratio of 2 to 3. I can write my ratio as 2:3. I could write it as 2 to 3, or I could write it like a fraction. So I could write it as 2/3. So I have cats to dogs. Okay, now let's say that they were asking about how many dogs to cats. If they were asking how many dogs to cats, again, I would come over here and I would look at how many dogs there are. I have 1, 2, 3 dogs. 2, 1, 2 cats. Notice how the ratios are written differently. Because dogs comes first, I have to put the number for the dogs first. Cats come second, so I write the number for the cats second. So my ratio is 3 to 2 or 3 to 2. Any of these are correct. You can write it however you want, or a fraction of 3 to 2. Now, what if the question was how many dogs to animals? I would add up how many dogs there are, which we know is 1, 2, 3 dogs, so we would put the 3 here, to animals. This means we have to add up how many animals there are total. 1, 2, 3, 4, 5. There were 5 animals total. And you could do it on the other way as well. Animals to dogs, cats to animals, animals to cats, whatever's being pictured here. Okay, I want you to please do a try it for me. So you are going to do a try it for me. So the try it says, let's go down here, try it. Okay, the try it says, I want to know how many dimes to pennies. So I'm going to use a D for dimes and a P for pennies, okay? So it says, all right, so dimes, 2, 3, and pennies. Okay, so you're going to write that out. Remember, that's like money there. I'm just not drawing money for you. You can draw the money if you want to draw the money. Okay, dimes to pennies or pennies to dimes. I'm asking you for your try it. I want to know how many dimes there are to pennies. How many dimes to pennies? All right, go ahead and tell me. Hit pause so that you don't see the answer. All right, so there's 1, 2, 3, 4, 5 dimes to 1, 2, 3, 4, 5, 6 pennies. And I could have written it as 5 to 6 or 5/6. Okay, how did you do on this first try it? Do you understand how to compare and how to write your ratios? Go ahead and put your rating in the box. And then when you're done, go ahead and flip the page if you need to. If not, keep adding your notes right there. Okay, so now we're going to look at how do we know if ratios are equivalent. So we're going to be looking to see if we know if ratios are equivalent. So we're going to compare. So we know that ratios compare things. So I have 2 ratios and each of them are comparing things. So I have a ratio that looks like 4 to 3 and another ratio that is 20 to 15. And I want to know, are these 2 ratios equivalent? Are they comparing the same quantity? Or do they have the same value? So what we're going to do is we're going to look at both ratios. So the first ratio that we have is 4 to 3. So we're going to look at 4 to 3, and we're going to compare it to the second ratio right here, which is 20 to 15. So the second ratio is 20 to 15. How we compare these is by looking at the change. So we're going to see what the change is to get from one to the other and see if they were equivalent. So we're going to look and say, how do I get from 4 to 20 or from 20 to 4? Well, I know that in order to get to 20, I have to multiply by 5. So we're going to multiply by 5. So the change on this side is multiplying by 5. On the other side of that, you could have divided by 5 if you were working backwards. On this side, how do we get from 3 to 15? Well, we multiply by 5. So the change here is times 5 on both sides. So these ratios are equivalent. They are equal. So these are equivalent because they change by the same number. And that's either, we want it to either be multiplied or divided. Okay? We do not want to look at addition or subtraction. So these two ratios are equivalent because their change is driven by the same number. And we're looking at either multiplication or division. Okay, let's do another one. Okay, here's another example. This example says the ratio of 5 to 7 and the ratio of 10 to 21. 5 to 7 and 10 to 21. We want to know, are these two ratios equivalent? So we're going to first compare 5 to 7. And we're going to compare 10 to 21. Okay, so we're going to look and see how do we make the change. So to get from 5 to 10, I'm multiplying by 2. Or I could reverse it and go division by 2. But to get from 7 to 21, the change is multiplied by 3. So because the ratios do not have the same multiplier between them, they are not equivalent. So this one is not equivalent. Another way that we can look at this is we could set them up as fractions and see if they are equivalent fractions. For example, in this one, I could have looked at 4 over 3 compared to 20 over 15. Did I multiply by the same numerator and denominator to see if these are equal? Well, over here, if I did times 5 over 5, then yes, they would be equivalent ratios because the change is the exact same. We have the same numerator and denominator. Now, if I was looking at part B, where I had 5 over 7, and I want to know, is it equal to 10 over 21, I would need to see, am I multiplying by the same numerator and denominator to get an equivalent fraction? Fractions and ratios are the exact same thing. They compare two things, a part to a whole, or a part to a part, or a whole to a part. And so when we're looking at this, we're looking to see, did I make the same change? So 5 times what gives me 10? Well, 5 times 2 equals 10. 7 times what equals 3? Well, 21. Well, 7 times 3 equals 21. This is not equivalent. So this right here is not equivalent. So no, these two ratios here are not equivalent because, again, different, right? It's a different numerator and a different denominator. Okay, it is your turn to do a try it. We're going to do 2 try it's right now, and I want a different color. Where is my blue? There it is. Okay, so I want to do 2. We're going to do 2 of them, okay? So this would be try it number 4. And try it number 4 says, it says 1 to 1 and 6 to 6. Are those equivalent? Are they equivalent? I mean, you can probably look at it and see right away. Okay, and then try it number 5. I don't know why they gave you such a simple one to do on that one. Okay, and then try it number 5. 1 to 2 and 3 to 4. Are they equivalent? So hit pause right now so you don't hear me. And then when you're ready, go ahead and hit play again. All right, so I want to know, are these 2 things equivalent? So I'm going to start with my first one, 1 to 1, and my second one was 6 to 6. And when I compare these, I know to get from 1 to 6, I'm multiplying by 6. And to get from 1 to 6, I'm multiplying by 6. So yes, these are equivalent. So these are equal. Okay, now this one, I want to know, what about 1 to 2 and 3 to 4? So my first ratio is 1 to 2. And now I'm looking at this one of 3 to 4. Well, to get from 1 to 3, I'm multiplying by 3. And to get from 2 to 4, I'm multiplied by 2. So these ones are not equal or not equivalent. All right, and I know that because it's a 3 over 2, and this one was a 6 over 6. All right, now I want you to answer your essential question. How do you know if a ratio is equivalent? And I want to know, what is a ratio to begin with from the front page. So what's a ratio and how do you know if it's equivalent? And then out somewhere in your box, I want you to tell me, what's your understanding of making equivalent fractions or ratios? We're going to be doing this again in our next lesson, but we will be using ratio tables to help us organize our data. So that's coming up soon. All right, go ahead and head on over to Google Classroom and ask for help if you need it, if you have any questions. Otherwise, you can go to Big Ideas and you can start working on your practice work. Thanks, Cougars, and as always, make it a great day the Cougar way.